So in this video, we're going to be talking about a concept known as the multiplier. And more specifically, we're going to be talking about the expenditure multiplier in macroeconomics. So what is the expenditure multiplier? Well, it is basically the change in output on GDP due to a change in autonomous spending. Now, change here refers to how many times is Y going to change, alright? And autonomous spending over here refers to the spending that is not influenced by the income level at all. I think you already know what is autonomous spending from the previous videos, right? So some examples of autonomous spending could be C0, I0 minus I1R, which is the investment portion, government spending, autonomous exports as well as imports. Okay, so these are examples of autonomous spending. So what the expenditure multiplier is telling us is this. For every $1 change in autonomous spending, by how many times does income change? To express this on a mathematical form, what it would be is income is equals to the autonomous expenditure multiplied by a multiplier, right? That's why it's called a multiplier. Okay, so A bar over here actually refers to autonomous expenditure. Okay, so in other words, to calculate your expenditure multiplier, you simply have to differentiate Y with respect to autonomous multiplier, right? And since the multiplier has a power of 1, so when you differentiate Y with respect to A bar, you simply get the multiplier. Okay, so that is how you calculate the multiplier. So let's go into detail, and I'm talking about the mathematics part on how we're going to calculate the multiplier. So we're going to apply 4 very simple steps to this. Okay, the first step, which I hope you should be really good at, is to write down the AE equation. Okay, write down the aggregate expenditure equation. So at equilibrium, AE equals to Y, which is also equals to C plus I plus G plus X minus M. Okay, so we expand those according to the assumptions that we're going to make about the economy. So the second step will be to bring all the Y terms to the left-hand side of the equation. So basically, it's everything that has got Y part of it. So for example, C1 times Y. Okay, so that is the left-hand side of the equation. We want to put all the Y-related items on the left-hand side. Okay, now the third step is to group all the right-hand side figures, the remaining right-hand side figures, into A bar. Okay, so A bar is your autonomous expenditure. It is things like C0, taxes, as well as your government spending. So the right-hand side will be known as A bar. Okay, now the last step is to simply make Y the subject of the entire equation. Okay, so what that means is that you bring everything else to the right hand side so that Y becomes the subject. And what you realize is that this dots over here will be the multiplier. Okay, so that's like a quick summary of how you can actually derive the multiplier using your A equation. Okay, so this is just a quick summary and quick 4 steps. Now just let me use 2 examples to show you how this is going to work in action. Okay, so we got 2 examples. We got economy A and economy B. Let's assume that both economies are closed and there is a government in both economies. Now the only difference is that economy A is going to have a lump sum tax, right? And economy B is going to have a proportional tax. So let's start with economy A first. So the first step, of course, is to write down your AE equation as such, right? So this is my AE equation, standard one with lump sum tax, okay, and this is actually the end of step 1. So step number 2 is to bring all the Y items onto the left hand side of this equation. So if I expand that bracket of C1 multiplied by Y minus T, I notice that C1Y has got Y in it, right? So I'm going to bring that to the left hand side, and that's the end of step 2. Okay, there's only one Y item in this equation. So step 3 will be to group all the right hand side stuff into A bar, and as you can see over here, I think this is probably the easiest part. Okay, and step 4, I need to make Y the subject. So I'm going to factorize Y out of the left hand side, and I'm going to divide both sides by 1 minus C1. So that is the end of step 4, and you'll notice that I actually already have the multiplier, which is over here. Okay, so this bunch of terms over here in front of A bar is known as the multiplier. Alright, we've seen this when we differentiated the Y with respect to A bar. Okay, you simply get the thing that is in front of your autonomous expenditure, okay? And that is 1 over 1 minus C1. Now, looking at the case whereby you have an economy with a proportional tax, so let's do it step by step again. Now I'm at step 2. I'm bringing all the Y items to the left. Okay, I'm going to group all the right-hand side stuff into A bar. Okay, now I'm going to factorize y out of the left hand side and divide both sides by that chunk that you see over there. Okay, so this is the multiplier for economy B. So as you can see, we're using these 4 steps. It's actually very simple to derive your multiplier. Okay, one of the challenges that you might face is they're going to ask you, so which multiplier is bigger? Okay, is it going to be multiplier of economy A, which is 1 over 1 minus C1, or is it going to be the multiplier of economy B, which is this chunk of stuff over here? So which one is bigger? If you are good at math, you should be able to already identify that, but let's take a look at this. So we know that since t is less than 1, 1 minus t will be less than 1 as well. So C1 multiplied by something that's less than 1 would obviously be smaller than C1, right? So now that you know C1, okay, is bigger than C1 multiplied by 1 minus t, what you can conclude is that the multiplier of economy A has a smaller denominator than the multiplier B, right? So what this means is that the multiplier of economy A is going to be bigger than the multiplier for economy B, because 1 divided by a smaller figure gives you a bigger number. Okay, so that is how you can identify whether MA is bigger than MB or not. The question is bigger better? Well, does size always matter? Well, this is something that we'll explore a little bit later. Okay, to some of you maths geniuses out there, you might think that this is a piece of cake. Okay, so what I'm going to do now is I'm going to look at more complicated multipliers. So my question to you is, what if you have a multiplier that has got so many variables in it? Okay, I'm not asking you to compare multipliers now, but I'm asking you, okay, what happens to the multiplier when one of these variables are going to change? To answer this question, obviously, I'm going to need a very complicated multiplier. Okay, so I'm going to make an assumption of a certain economy so that we can work from there. Let's assume that there is an income gap between the rich and the poor. So the rich people are earning 1 minus alpha percent of the income, and the poor people are earning alpha percent of the income. Okay, and each of them have got different marginal propensities to consume, and we'll assume that the poor people have a larger marginal propensity to consume. Let's assume that this is a closed economy, and let's also assume that this is a balanced budget policy, and government spending depends on the amount of taxes that's being raised. And let's also assume that the tax system here is a proportional tax. So T times Y is the total amount of tax that I calculated. But I think you might be asking, don't I have to separate the amount of taxes collected from the rich and the poor? Well, the answer is no. Well, let me show you mathematically why this is the case. So the amount of taxes that the rich pay is T times 1 minus alpha percent times Y, right? And the poor people are paying T multiplied by alpha percent of the income. So to calculate how much taxes the government collects, you just simply add up the total taxes taken from the rich and the poor. So I'm going to add up these two figures together. And what you realize is that I actually end up with small letter t times y. So that is why the balanced budget, okay, given that is dependent on taxes, government spending is equals to simply t times y. Okay, so that was the easy part. Now let's take a look at the aggregate expenditure equation. Okay, so we'll begin with at equilibrium, AE equals to y, which is equals to C plus I plus G. And I'm now going to expand all these components out into their respective forms. So this is my consumption function. Alright, and this is my investment function. And we've got government spending, which is small letter t times y. So you'll notice that this is actually the end of step 1 to finding my multiplier. Okay, so the second step will be to bring all the terms with y onto the left-hand side of this equation. Okay, so this is what I'm doing right now. So this is the end of step 2. Now step 3 will be to group all the right hand side stuff as a bar, and simultaneously I'm just going to factorize y from the left hand side of the equation. Okay, so this is the end of step 3. Okay, we're almost at the end now. Step 4 will be to simply make y the subject. So I'm simply going to bring all the bracketed terms to the right hand side of the equation, by dividing both sides by the bracketed terms. Okay, so I'm going to get y equals to a bar multiplied by 1 over all the bracketed terms. Okay, and this essentially brings me to the end of step 4, and I have successfully defined my multiplier. Okay, so this chunk of stuff over here in this red box is my complicated multiplier. Now I need to answer the question of what is going to happen to the multiplier when each of these variables change. So what I'm going to do to simplify things is I'm going to take this chunk of stuff in this green box and I'm going to factorize the whole thing by -1. So what this looks like is this. Okay, so I'm going to have a bracket within those bracketed terms. Okay, and I'm going to take away -1, and you notice that the signs inside start to change. So I can further replace this by writing in this form. Okay, y equals to a bar multiplied by 1 over 1 minus m, where m is that complicated bunch of stuff that you see in the bracket above. So, what happens to the multiplier when the poor people start to earn a larger portion of the GDP? Well, in this case, what we're trying to say is that alpha has increased. So what I'm saying is that if you look at the poor people's income, okay, which is alpha times y, this whole figure will increase because of an increase in A. And the rich people will start to earn less, okay, because of an increase in A. 1 minus a bigger A would be a smaller figure. So I'm not saying that there are more or less poor people, I'm just saying that the poor people are earning more at the moment, okay, due to some reason. So let's take a look at M, okay, where M represents all these chunks of algebra over here. Okay, so what we're going to do is we're going to differentiate M with respect to A, and I'm going to get this bunch of stuff. So you might be asking me now, why are we going to differentiate M? Why do we have to do that? Well, the answer is simple. Well, that's because we want to find the rate of change. Are we talking about the size? No, we're not trying to find the size of the change. We're trying to find whether this rate of change is a positive one or negative one. So basically what we're trying to find out is when A increases, does M decrease or increase? So that's what we're trying to find out. Okay, so this is a little bit of basic math. So I'm gonna simplify the equation into this form. So 1 minus t is obviously positive, and C1p minus C1r is also positive because C1p is more than C1r. Therefore, positive times positive gives me a positive. So a positive outcome basically means that there is a positive relationship between M and A. When A increases, M is going to increase. When A decreases, M is going to decrease. And we can now conclude. Therefore, when A increases, we know that M is going to increase. Okay? And this is due to that positive relationship. Now, let's take a look at the multiplier again, which is 1 over 1 minus M. Now, when M increases, this means that the denominator is going to fall. So with a smaller denominator, the multiplier is going to increase. So in conclusion, when the poor people are earning a larger portion of the GDP, your multiplier is going to increase. Okay, so this is one of the ways that you can actually analyze a complicated multiplier. Okay, analyze the change, the direction of change, etc. Okay, using a simple differentiation method. Okay, so why is there a expenditure multiplier? Okay, what is the intuition behind the existence of this thing? Well, it is because of the AE equals to Y equilibrium, which basically says that our expenditure is someone's income. Okay, so in order to show you how this is going to work, I'm not going to show you math. Okay, I'm just going to show you a simple example. Alright, let's just say that in this economy, there is a large company that invests $10 million into a factory. Okay, so this $10 million over here, which is also known as I0, the autonomous investment, this is actually income. Alright, income to who? Well, it might be income to the electricians, to the engineers, to the architects, and even the project managers, people that contribute to building that factory for that company. If we assume that the MPC is equal to 0.5, then this bunch of people here are going to be spending $5 million of that $10 million income. So they'll be spending $5 million on businesses that are selling maybe some goods and services, right? So this $5 million, okay, is actually the amount that is spent by this bunch of people. Okay, that's expenditure, but it becomes income to the businesses selling other goods and services. So again, if the MPC is 0.5, then these businesses will be spending 2.5 million on maybe the other businesses that are also selling goods and services. I mean, business owners need to have fun as well, right? They need to buy stuff too, right? So these businesses spend that 2.5 million, which is earned by these other businesses. Okay, so you can go on, so on and so forth. And what you notice is this. You will notice that this $10 million of investment by that large company, okay, actually creates a whole string of income for the entire economy. We just got to keep dividing that 10 million by 2 because the MPC is 0.5. So you go so on and so forth. Okay, so this is actually the multiplier in effect. Okay, we call this the multiplier effect. Okay, the additional income resulting from that expenditure of $10 million from that large company. Okay, so I hope this little example can help you to understand why there is this multiplier. So the next question is, why do we have to understand the multiplier well? Well, it is because by understanding the multiplier well, we can actually identify what would be the impact of a change in demand on an economy. So demand here actually refers to your aggregate expenditure. Okay, things like your government spending, your autonomous consumption, investment, as I've seen earlier, as well as autonomous exports. Okay, it also helps policymakers to identify how much they have to increase that kind of demand or decrease the demand to achieve certain goals. So such goals might include increasing the GDP to get out of a recession or to get votes, decrease the GDP so that you can fight inflation, or maybe even to bring the economy back to its natural rate of output. Okay, so these are the different types of goals that policymakers can hope to achieve. Okay, so another reason is because we can now understand what is the impact on random shocks, and shocks here are shocks to economy. Okay, so it might be a change in demand that nobody has expected, even the government as well. So we need to be able to understand what is the impact. So again, the question is a bigger multiplier a good thing? Well, not exactly. Here's the reason why. Let's say that you've got a super big multiplier. Okay, so with a big multiplier, while a small increase in autonomous spending can actually create a big increase in your income, at the same time, a small decrease in your autonomous spending can actually create a large decrease in your income. So that's a bad thing, right? Especially when the small decrease in autonomous spending is an unplanned one, it's unexpected. So you see, that's why bigger isn't always better. Okay, so how is the multiplier reflected on the graph? Well, let's look at one of the graphs first, and we're gonna look at the Keynesian cross diagram. I hope you remember what this is. So you know that the Keynesian cross diagram has got AE on the vertical axis and output on the horizontal axis, right? So just to let you know, y equals to a bar multiplied by the multiplier is not the equation of the AE function. Okay, it is not. Let's take a look at the Keynesian cross diagram, shall we? So just let me quickly draw it out. So these are the two axes, and you're going to have a 45-degree AE equals to y dotted line. So that is the AE function. Okay. When the multiplier is going to increase, what you'll notice is that you're going to get a steeper AE curve. Well, why is this the case? Well, I think with a little bit of common sense, you might be able to figure that out. Okay, so look, with a higher multiplier, I'm going to have a obviously higher output as compared to a flatter multiplier. So the reason why it's a steeper AE is because you're going to have a larger income given a level of autonomous expenditure. So at the same time, when the multiplier is going to fall, you're going to have a flatter AE, which looks something like this at AE2. So you're going to have obviously a smaller output given the same amount of autonomous expenditure. Okay, so it's pretty simple. Now, the other case where the multiplier is reflected on the graph is of course on the IS curve, which we will be going through in the other videos. This is important because you actually have to use your Keynesian cross diagram to derive your IS curve. Okay, so when something affects the Keynesian cross, something is going to affect your IS curve. So we'll go into that in the later videos. Okay, so there are actually other types of multipliers. We talked about the expenditure multiplier. There are two other multipliers I can think of. So one of it would be the government spending multiplier, and also the money supply multiplier, which we will be going through again in another video. So let's take a look at the government spending multiplier. It is basically the change in Y over the change in the government spending. So as you can see from here, it is basically just taking your equation for income, okay, your AE equation. After you bring everything, all the Y stuff to the left hand side, you differentiate that guy with respect to G. Okay, so let me just show you a mathematical example over here. Okay, so I've got a simple, I've got an open economy here, in fact, okay, and I've got proportional taxes as well. So let me just show you how I'm going to derive the government spending multiplier. This is just for your general information, by the way. So, okay, this is actually step 2. Okay, you can see that I'm bringing all the Y related stuff to the left hand side. Okay, I'm leaving all the non-Y stuff on the right hand side. So I'm just going to bring G to the end. And what I'm going to do is I'm going to isolate Y. I'm going to make Y the subject. Okay, so I'm going to make Y the subject. And notice that the stuff in front of G would be simply this. It is 1 over the bracketed terms. So I'm going to differentiate Y with respect to G. So what do I get? I get this bunch of stuff over here. So basically, this bunch of stuff, okay, in this red box, is your government spending multiplier. Okay, so it's really that easy to calculate. Okay, with that, I think you're already pretty good with the multiplier. That is the end of the video. We'll see you in the next video when we talk about the IS curve. Meanwhile, I want to thank you for studying with Quickienomics.